Hey guys, we're going to go the next layer with factoring, and we are going to kind of look from lessons 8.5 all the way through 8.9 on solving equations by factoring. Okay, so let's talk about the process of how do you solve equations. So let's again remember we've got a quadratic equation, takes on this form, ax squared plus bx plus c equals 0. Now we've got a quadratic equation, okay? So this is a quadratic equation. And what makes it quadratic is the squared term, okay? So the quadratic term is the first one, so that's your quadratic term. Now let's do this way. And we're going to call A the quadratic coefficient. Quadratic coefficient. Okay, and then we've got B, x is the linear term. You saw that a lot when we were in linear equations. And again, B is going to be the linear coefficient. And C is called a constant. Because it's generally just a number, though sometimes they have variables. So in order for it to be the quadratic equation, we got to have the quadratic polynomial is going to be written in descending degree order on the left with a 0 on the right. Okay, so to solve an equation, so again, first, the polynomial is on the left, and it's got to be in standard form. Which is what we wrote up above, ax squared plus bx plus c, that's what's on the left, and 0 on the right. And when I'm saying on the left and on the right, we're talking of the equal sign. So then we're going to factor the trinomial, or I'm just going to say polynomial, because we could have all sorts of different combinations. Okay, and this is the one thing hopefully you figured out. Look for a GCMF first. Now, if you don't see it at the beginning, double check your binomials to see if there's something more that you can factor. Okay? Now, we're going to use something called the zero product property. Okay? Now, I didn't list down the process that we use to factor because we talked about the product sum game and factoring by grouping. I've also demonstrated in class you can be listing the factors of A and C and seeing how to combine them to get the B. Big thing again, remember, pay attention to your signs. So the third guy we're going to use is zero product property. And basically what this property says in order to get an answer that's zero, you have to multiply by 0. Okay, so it's basically saying A times B equals 0. If that's true, then A equals 0 or B equals 0. Okay, so in our case, the A is going to be a factor, and the B is going to be a factor. Okay, so what are we going to physically do? We're going to set each factor equal to 0, then solve. Okay, and then because we are going to get more than one answer, we're going to write our answer in a special way, and we're going to write the answers in solution set notation. Okay, so that means braces, and then you would list your answers separated by a comma, and there you are. Okay, so I'm going to give you a whole bunch of different examples. So I'm going to find a couple here. We'll go to my next screen. And they're kind of going to go in order from 8.5 to 8.9. So directions are going to be solve, okay, let's see if I can find one. Yeah, okay, and yeah, so we'll start with this one. So sometimes you will get an equation that's already been factored, which eliminates a lot of problems for you, a lot of things we need to do. So we're going to take each one of those factors and set them equal to 0. Okay, so let's see. So we're going to do inverse operations. I'm going to subtract 6 from both sides on the first one and add 15 to both sides on the second one. That's going to give me 2d equals negative 6, and 3d is equal to positive 15. First one, I'm going to divide both sides by 2. Second one, divide both sides by 3. That's going to give me d equals negative 3, and d equals 5. So we're going to use solution set notation. And again, it doesn't matter the order that I write things. Okay? So, you may have something that looks like this, where they give you a polynomial. In this case, we do have a binomial. And what we're going to do is try to factor. I notice that they both have an 8 and a b in common. So 8b squared divided by 8b is b, minus 40 divided by 8 is 5, b divided by b is 1. So then I'm going to take each of those that contain a variable and set it equal to 0. And then I solve. So on the first one, I'm going to divide both sides by 8. On the second one, I'm going to add 5 to both sides. That gives me b equals 0 and b equals 5. So the solution set contains 0 and 5. Okay? Now, I am going to be talking about some other language. I think I'll wait to do it till the next video. I think I will do that. All right, so let's go up a little bit and let's talk about a problem where we're going to solve. And we've got x squared plus 6x equals 27. So first problem I see is this is not written with the polynomial in standard form and 0 on the other side. So I'm going to do that first. I'm going to subtract 27 from both sides. Now I have the polynomial x squared plus 6x minus 27 equals 0. So to factor, I'm going to play the game. I'm going to think of factors of negative 27 that add, or no, sorry, I apologize. Negative 27 with a sum of 6. So to get a negative product, I have to have different signs, and the bigger factor I get is going to go with the plus sign. So factors of 27 are 3 and 9, and they subtract to give me 6, which is exactly what I need. So I put the 9 with the positive, the 3 with the negative, so when I add I get a positive 6. So that gives me x squared, I'm going to put the negative first, minus 3x plus 9x minus 27 equals 0, and then I factor by grouping. I get x times the quantity, x minus 3, and then plus, because remember he comes down, and they have a 9 in common, and that's going to give me an x minus 3. So it gives me x minus 3 times x plus 9. Now here's the, we did all of that, where as the first problem that was all done for us. Now we use the zero product property, and we set each factor equal to 0, and we solve. I'm going to add 3. This one you're going to subtract 9. That's going to give me an x equals 3 and x equals negative 9. So the solution set contains 3 and negative 9. Okay. Let's go in and we'll talk about having, all right, let's see, we've got a problem here, and I'm going to give you a problem. So this is this pretty stereotypical word problem that you would see with quadratics. So a person, so I'm going to turn this off, I'm going to pause it, write it down, and then when you open, I come back on, you're going to pause it and write the problem down. Okay, so this one, a lot of words, but it's super important to write this down. A person throws a ball upward from a 506-foot tall building. The ball's height is h after t seconds is given by the equation h equals negative 16t squared plus 48t plus 506. The ball lands on a balcony that is 218 feet above the ground. How many seconds was it in the air? So go ahead and take a moment, pause the video, and write the problem down. Okay, so when I come to word problems like this, I kind of like to visualize what's happening. So we have a building, and there's this balcony that is, here's your ground, and the distance is 218 feet above the ground. We were told at the very beginning that the building is 506 feet tall, and you've got somebody that's standing at the top, and they're throwing a ball up, okay? So it comes down and it lands on that balcony, okay? So it says the ball lands on the balcony, so we know where it's at height-wise, and we want to know how long it took to go from the air onto that balcony. So we have one thing that's missing from the equation, and that's this final height that it reaches. That's going to be our h. So we're going to write our equation is 218 equals negative 16t squared plus 48t plus 506. So what we're going to do is we're going to get everything on one side, 0 on the other, and then I'm going to rearrange it so that it's in polynomial on the left. So I'm going to use the symmetric property. I get negative 16t squared plus 48t, and then plus, and then I have to do a little math over here. I have to rename, so I get an 8, an 8, and a 2. Now all of that's going to be equal to 0. And I know what you're thinking. Holy smokes, how am I supposed to solve this problem? How am I going to factor this? Well, I'll give you a little hint. Pretty much on these problems, all the numbers have a GCF, and that GCF happens to be 16. Now, I don't like that negative, so I'm going to take it out at the same time. But I treat every term on both sides of the equation exactly the same way. So where does that lead me to? I get t squared. Signs are different. I get a negative. 16 goes into 48 3 times. So I get 3t. And then again, I'm going to get another negative. 16 goes into 28 once with 12 left over, which is going to give me 128. And 16 goes into 128 8 times evenly. Okay? So now let's play the game. A lot simpler, isn't it? So we have a product of negative 18. We have a sum of negative 3. So 18, let's see, 2 and 9. No, that would be 7, 6, and 3. There we go. So the bigger factor is going to go with negative because that's what I have left over. So the 6 is negative and the 3 is positive. So now we're going to continue this problem. We get t squared minus 6t plus 3t. Let's see, minus 18 equals 0. So then we're going to factor by grouping. We're going to pull out a t, and that gives me a t minus 6. And then we're going to pull out a positive, and it looks like a 3 from these two, and that's going to give me a t minus 6. So we factor out the common binomial, and we get another binomial formed. We set each one of those equal to 0 and solve. So we're going to add 6 to both sides. Oh, sorry. Try that again. Add 6 to both sides on the first one, and we are going to subtract 3 from both sides on the second one. There we go. That makes more sense. So I get t equals 6 and t equals negative 3. Now, we have to use some logic here. We can't have something in the air for a negative time, so you have to look for answers, and if they aren't reasonable, then we check them out. So we would say, we're going to use this as our answer. The ball was in the air for 6 seconds. That's how long it took for that ball being thrown upward from the top of that building to land onto the balcony. Okay? Okay, so now we're going to do, show you a couple different things going on these problems. We're still doing the same directions. So let's see, I forgot what number we're on, 5. All right, so I want to talk about some evil things. First off, let's say we have t squared minus 16 equals 0. Okay, no, let's actually change it. Let's make it t to the 4th. So this is what we talked about in class called the difference of squares. That's the answer we get when we multiply two binomials that have the same front term, so like A, same back term like B, and we have one sum and we have one difference. So the answer would be, if I multiplied a squared minus b squared. So we're starting with something like the a squared minus b squared. So I'm going to show you two ways to solve a problem like this. First one is, I'm going to go ahead and take the square root of each of those numbers. that's going to be a t squared. Now that's going to show up 2 places. Okay, then I'm going to take the square root of 16, and that's 4. And that's going to go in 2 places. Then we're going to create our binomials. We're going to get one sum and one difference. The only thing you have to do is look at the one with the subtraction and ask yourself, are those perfect squares being subtracted? And the answer is yes. So when I factor, and by the way, let's add in the equals 0, I still have a t squared plus 4. He's not going anywhere. But now I'm going to create 2 new binomials. What are they going to be? Well, the square root of t squared is t. Remember, we're always cutting the exponent in half. And the square root of 4 is 2. I'm going to get one sum and one difference. Okay? Now, we're technically going to set each of these factors equal to 0. And solve. So the first one, we're going to subtract 4 from both sides. Second one, we're going to subtract 2 from both sides. The last one, we're going to add 2 to both sides. So we get t squared is equal to negative 4. We get t is equal to negative 2, and we get t is equal to positive 2. The problem is there's a rule about taking square roots, and you can't take the square root of a negative number because it's always something being multiplied by itself. And there's no way to get a negative number when you're multiplying 2 numbers by itself. So if I tried to take the square root of both sides, I would get t is equal to the square root of negative 4, which is impossible. So it gets thrown out. So I do have 2 answers here. So I'm going to put them in solution set, and I can have one positive, one negative, and I can write them that way or I can write them out separately, whichever way I want to. But the key is to pay attention that sometimes we might have a factor that is a perfect square. Now I am going to talk about briefly, what if you have a problem like that one? Let's do another one. Let's do this guy. So another way to solve, if you have 2 terms, both are perfect squares, 9 is a perfect square, 16 is a perfect square, and they're separated by a negative, what I can do is something called the square root property. Okay, and the square root property says this. If I have like x squared and it equals some number, then I can take the square root of each side. However, I don't know whether that number was a positive number, because a positive times a positive is a positive, or it's a negative number. A negative times a negative is a negative? No, it's a positive. So that's what we're going to get. So in other words, x is going to be equal to, because the square root of x squared is x, we take the exponent, cut it in half, and then whatever the square root of that n value is. Okay? So this only works, the linear term must be missing. Binomial is the difference of squares. Okay, so on this one, what we want to do is isolate the squared term. So we're going to add 9/16 to both sides. Okay, that's going to give me x squared equals 9/16. Now, if this was negative, I couldn't do anything with this, right? So now I'm going to take the square root of both sides. But as soon as I put a square root over a variable, I need to add plus or minus in front of the other side. So the square root of x squared is x. Then I'm going to get plus or minus, and then I'm going to take the square root of each number. So the square root of 9 is 3, and the square root of 16 is 4. So my solution set contains 3 and negative 3/4. So that's kind of a nice trick if I have a difference of squares. All right, now the last example is going to look kind of interesting. We're going to have a binomial that's being squared, and it's set equal to a number. Well, think about that quantity x plus 6 squared as being x squared. So what we're going to do is take the square root of both sides. Now, when I take the square root, remember, I have to write plus or minus on the other side, and then take the square root of that number. Okay, now when I take the square root of something that's squared, I get that binomial comes out. So I get x plus 6. Now on the other side, I'm going to get a plus or minus, and then I run into a little bit of a problem. 12 is not a perfect square, but remember we've learned how to simplify. So I look for the perfect square factor of 12, which is 4, and its partner, which is 3, and I'm going to take the square root of each of those. Well, the square root of 4 is 2, and I can't take the square root of 3, so it just stays behind. Now, I'm not done yet because I have to get the x alone, so I'm going to subtract 6 from both sides. So we get x is equal to negative 6 plus or minus 2 radical 3. So there's an interesting answer for you. So how would you write the solution set? Exactly the way that I wrote it, or I could split it up and write negative 6 plus 2 radical 3, comma, negative 6 minus 2 radical 3. All right, and we'll do some more in class as well. All right, thanks, guys. Good luck with this. Bye now.